Hey, physics students, so we have talked about in this unit so far displacement and time. We've talked about velocity and acceleration. We've made some graphs of position versus time and velocity versus time. We've solved some problems using some equations, and now what we're going to do is we're going to go ahead to the next target, and we're going to talk about another big concept in physics, something called forces. Today we're going to talk about forces, and we're going to talk about the laws of motion. There's 3 laws of motion we're going to talk about. Newton's laws of motion. So today we're going to talk about forces and the laws of motion, and our target is to be able to solve problems using the laws of motion. So let's go ahead and let's talk about some of these things. Alright, so the first thing to talk about here, what is a force? Okay, a force, oftentimes people will say a force is a push or a pull on an object, right? So a force is a push or a pull. There are many kinds of forces that we could talk about. Force of gravity, pulling down on something. The force of friction, working on something. Force of tension in a rope. There's electromagnetic forces. There's lots of different kinds of forces that we could talk about. Today we're just going to talk about forces kind of in general, and we're going to talk a little bit about the force of gravity in a little bit here, okay? When we talk about forces, when we do math with forces, we'll use a capital F as a variable for force, right? So it makes sense. Force is capital F. And force is measured in a unit called the Newton. The Newton is named after Sir Isaac Newton, who was kind of the father of the entire field of physics. So the force is measured in the unit called the Newton. Newton is abbreviated with a capital N. And a Newton is a derived unit. It's equal to 1 kilogram meter per second squared. So 1 Newton is the same thing as 1 kilogram meter per second squared. A Newton is not a huge amount of force. A Newton, in our British imperial system, to measure a force, we usually use the pound, and a Newton is equal to about 1/4 of a pound, right? So if you want to think about how much is your weight in newtons, it would be about 4 times as much as your weight in pounds. So you might weigh, several hundred newtons. Force is what we call a vector, okay? A vector is something that there's lots and lots of things in physics that are considered vectors, okay? A vector is something that has not just an amount, but also a direction, right? Think about something like displacement is also a vector, right? If I told you that Chicago was 100 miles away, that's great. It's not going to help you get to Chicago, though, because you also need a direction. Right? These kinds of things are called vectors. So you can think about a force. I say there's, 3 newtons of force, but which direction that force is pushing or pulling is also very important, right? So certain quantities called vectors have both an amount and a direction, right? Some things don't, right? Some things aren't vectors, like mass, for example. If I say something has a mass of 12 kilograms, well, that doesn't have a direction. It's just the number. It's just what it is, right? There's no direction to that. So some things do have a direction. We call those things vectors. And some things don't have a direction. And force is a vector. So it has an amount and a direction. And that means that sometimes we have to be aware of which direction force is acting. Because let's say I have a force of, 5 newtons acting in this direction. And I have another force of 5 newtons acting in this direction. So since they're in opposite directions, we just have to be aware one of them is acting in the negative direction. Depending on which way you're looking at it, it could be either one, it doesn't matter. So 2 forces, if they're both 5 newtons acting in opposite directions like that, if I want to figure out how much total force, I wouldn't add them together, I would want to subtract them because they're in opposite directions then, right? Okay, one particular force that we're going to talk about here is a force, the force of gravity. Okay, the force of gravity is otherwise known as weight. Okay, weight is the force of gravity. Weight is a force. It's a force. It's the force that gravity pulls on something with. And we can calculate the force of gravity with a very simple equation. The force of gravity, we'll use F with the little g to stand for force of gravity. And the force of gravity is equal to the mass of the object times this number g. Okay, this number g here, this is the first time we've seen it, and this is a very important number for us. G, this lowercase g, is what we call the acceleration due to gravity. Whatever planet you're on has its own acceleration due to gravity. Here on Earth, we use this little g for the acceleration due to gravity. On different planets, it's going to be different amounts. But whenever you're doing a problem here on Earth, we can use a particular number for this lowercase g. Everywhere on Earth, it's about the same. It's 9.81 meters per second squared. Keep in mind that's an acceleration, right? It's the acceleration from gravity, so it has units of acceleration, meters per second squared. So this lowercase g, the acceleration due to gravity, and it is 9.81 meters per second squared. It's a number we're going to want to remember. We're going to see it again, we're going to use it again. Okay, so to find the force of gravity, all we have to do is take an object's mass in kilograms and multiply by g, 9.81 meters per second squared. And that'll give us the force of gravity in newtons. Pretty simple equation to use, huh? All right, let's talk a little bit about Sir Isaac Newton. I mentioned him a minute ago at the beginning of the video. Sir Isaac Newton is kind of considered like the father of the entire field of physics, right? There were people doing physics before him, but Isaac Newton was he's like the man in physics, right? He's the guy, Isaac Newton. So Isaac Newton, he was a mathematics professor at Cambridge University in England, right? He was an English mathematician. And, there was one year where the plague came to Cambridge. And as one does, when the plague comes to town, everybody shut everything down and moved out to the country, right? And Isaac Newton, being a math professor, shut his classroom down. He moved out to the country. They canceled school for the year. Everything was done. Everything was shut down. And he moved out to the country. And during that year out in the country, Isaac Newton wrote a book that contained within it all of the basic rules of motion that we know today. It's called the Principia. And in this book, not only did he write about a lot of the basics of physics that we know today, but he also invented calculus. So kind of a productive year for him. That was 1687, I think it was. And okay, so in this book he wrote about 3 laws of motion, and we're going to talk about these 3 laws of motion here. The first law of motion, you've probably heard them before. The first law of motion, sometimes called the law of inertia, it says that an object at rest will remain at rest, and an object in motion will remain in uniform motion unless it's acted on by an unbalanced force. So what does that mean? Just kind of, in general terms, that means without a force, an object's motion won't change. So if an object is sitting still, if you don't put a force on it, it's just going to keep sitting still. If you have an object that's moving, say it's moving along, that way at 2 meters per second, if you don't put a force on it, it's going to continue moving that way at 2 meters per second. The law of inertia, first law of motion, it says that an object's motion won't change unless there's a force acting on it. Sometimes called the law of inertia because inertia is this property of matter that it's going to want to continue to maintain its motion, right? Which is why it takes a force to cause it to change its motion. So that first law, the law of inertia, an object's motion won't change unless you put a force on it. The second law of motion is a fairly simple equation, right? The second law of motion, it says that the sum of the forces acting on an object is equal to that object's mass times its acceleration. And the acceleration will be in the same direction as the sum of the forces. right? So force equals mass times acceleration. And keep in mind units here, right? Mass is measured in kilograms, acceleration in meters per second squared. So you've got kilograms times meters per second squared, which is kilogram meter per second squared. And you remember, we mentioned a minute ago, force is measured in newtons, and a newton is the same thing as a kilogram meter per second squared. So all the units work out there very nicely. So the second law of motion, force equals mass times acceleration. And that's an equation that we can use to solve some problems in physics. And the third law of motion says that usually the words that people use, they say for every action, there's an equal and opposite reaction. Okay, and what it means by action and reaction is force. So for every force, there's an equal and opposite force to balance it out. So like, for example, if I press on the wall is going to press back on me with an equal amount of force, right? As I press on the wall, in order to not be pushed away from the wall, my feet press against the floor with the same amount of force that I press against the wall, right? So for every action, there's an equal and opposite reaction. For every force, there's an equal and opposite force, right? You can demonstrate this if you sit in a rolling chair, a chair with some wheels on it, and you push against the wall. What's going to happen? Well, you're going to move in the opposite direction that you pushed, right? I push this way, and it's going to cause me to move that way in the rolling chair. And that's because for every action, it's an equal and opposite reaction, right? The third law of motion. All right, so there is a little bit about forces and about the laws of motion. And so hopefully that helps us to be able to solve some problems using the laws of motion. So until next time, take it easy.